Hello everybody. Today we're going to be on our second day of implicit differentiation, and typical to how I run things in the classroom, we're going to start with something we know how to do. So for our do now, if I ask you to find an equation of the tangent line to the graph of y equals x cubed plus x at the point -1, -2, I hope you guys could jump right into this. Our equation is what we're used to seeing. It's in the y equals form, so we're just going to have to do what we already know. For the equation of a tangent line, we need the point, we need the slope, and then we plug it into our point-slope formula. So this is really an old question. Our point was given to us. We always like when that happens. And our slope, well, how do we get the slope again? It's the slope of the tangent line, so we have to remember we first have to find the derivative of this function. And once we have the derivative, we can just plug in 1, and that's going to be the slope of the tangent line. So y prime of, let's say, 1 equals 3 times 1 squared plus 1. So our slope is 4. So now that we have our point and our slope, we just pop it in to our formula. Y plus 2 equals 4, x plus 1. And we're just going to leave it like that because I don't want to keep you too long today. So yesterday we studied how we can use implicit differentiation to find the derivative of equations that are implicitly defined, meaning our x's and our y's together. Today we're just going to expand a little bit on that topic. We're going to show you that anything we already know how to do, we can now kind of incorporate implicit differentiation with that. So if we start with example 1. Given y cubed plus y squared minus 5y minus x squared equals -4, I want to find the slope of the tangent line at that given point. Whenever we want to find the slope of the tangent line, that means we have to find the derivative. So we're going to go back to yesterday's lesson and talk about the dy dx, dx thing. So we're going to look, I give it a quick look-see. Each term is nice and separate, so I don't have any product rule or anything messy going on. Go term by term. 3y squared dy dx plus 2y dy dx minus 5 dy dx. Remember, every time you take a derivative of a term with a y in it, you must write dy dx. Now I have an x. Minus 2x dx dx. Anytime I take the derivative of a term that has an x in it, I write dx dx. Equals the derivative of -4 is 0. So we're going to kind of group anything that has a dy dx in it. So these three pieces here, that cancels. These three pieces, I'm just going to sort of rewrite them as one single thing out front because they're all kind of together. It's like I'm factoring it out. Dy dx. Remember, this is one lump that moves together. Equals, I'm going to move the 2x to the other side. Now, to solve for dy dx, or to get dy dx by itself, I'm going to divide by this whole set of parentheses. And it's really easy to make mistakes with these. That's why I just kind of like to show you this year. You know, just try to be careful. I'm sure I'm going to make a mistake before the end of this lesson. Now that I have the rule for my derivative, if I want to find the slope of the tangent line at that given point, I'm just going to evaluate this derivative at the point 1, -3. And sometimes this nice little calculus notation to sort of remind yourself what you're doing. So whenever I see an x, I'm going to plug in 1. And whenever I see a y, I'm going to plug in -3. And this is a matter of simply just evaluating, and you should get 2/16, which is 1/8. So the slope of the tangent line for this given curve, whatever it looks like, I don't know, but the slope of the tangent line is 1/8. Let's do a few more examples, and hopefully will be a shorter day today. Okay, so now we're going to look at example 2 together. Determine the points where the curve has a vertical or horizontal tangent line. So here I have to remember certain things about vertical and horizontal tangent lines. First of all, if I have a vertical tangent line, that means my tangent line is going to look like that against the curve, however the curve looks. So if I have a vertical tangent line, it means the slope is undefined. And where is something undefined? When the denominator is equal to 0. And if I have a horizontal tangent line, that means my line is going this way. What do I know about a horizontal line has a slope equal to 0? And if I'm dealing with, because remember, when we want to get the slope, our slope now is dy dx. So my rule has a numerator and a denominator. So in the first case, vertical, I set the denominator equal to 0. When I'm looking for a horizontal, I'm going to set the numerator equal to 0, right? Because numerator equal to 0 makes the whole thing 0. Denominator equal to 0 makes it undefined. Okay. So obviously, I'm going to have to find dy dx in order to answer anything. I go back up into my given curve. 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. Once again, we're dealing with a nice, easy, implicit curve here. So we're just going to go term by term. 8x dx dx plus 2y dy dx, right? Minus 8 dx dx plus 4 dy dx plus 0 equals 0. And now I'm going to cancel out anything that has a dx dx in it, and there. And I know I'm going to leave these two on this side, so I'm just going to kind of write them 2y plus 4 dy dx equals, now what do I move over to the other side? My 8 minus 8x. So the rule for the derivative of this function, dy dx, is going to be 8 minus 8x over 2y plus 4. You can leave it just like it is, or if you want to simplify it, that's fine. Okay. If you notice, everything here is divisible by 2, so I can just divide everything by 2 and make my, if I have to evaluate things, make things easier, a little bit easier to work with. Okay. But that's not totally necessary. Okay. So now that we have the rule for our derivative, okay, we're going to go back up and we're going to look at specifically what we want to show. Okay, we want to find the points where we have a vertical line and horizontal lines. Okay. So if we want to find where something is vertical, remember that's where we're going to take and we're going to set the denominator equal to 0. So I go over here, y plus 2 equals 0. I'm going to have vertical tangent lines whenever my y value is negative 2. But I want to find the points. Okay, I need the points. So how do I get the points? I have to use the original function. Or this is not a function, I have to use the original equation. So I'm going to plug negative 2 into our original equation and get the x values that go with this y value. So 4x squared plus my y is going to be negative 2 squared, minus 8x, that's what I'm looking for, plus 4 times negative 2 plus 4 equals 0. And all I did was I took this equation and every place I saw a y, I replaced it with negative 2. So to continue on here, I get 4x squared plus, I've got 4 here and negative 8 here, and 4 here. So overall, that should be, that's going to make me have a 0, right? So that's just going to cancel. So I have 4x squared minus 8x. There we go. I was just messing up a tiny little bit there. 4x squared minus 8x equals 0. So I need to solve this. 4x, x minus 2 equals 0. That's going to happen when x is equal to 0 or x is equal to 2. Remember, we want to write these as points. So my 2 points are 0, negative 2, and 2, negative 2. Now let's talk about how we can find where this curve has horizontal tangent lines. That's going to be when the numerator equals 0. So I go back up into my derivative. I set the numerator equal to 0. And that's going to be 4x equals 4, so when x is 1. Okay. So whenever x equals 1. Now to find the points, once again, we're going to go back up and plug in this original. We're going to replace x with 1 and solve for y. So I have 4 times 1 squared plus y squared minus 8 times 1 plus 4y plus 4. And this becomes 4 plus y squared. I'm going to work a little slower this time. Hopefully not make as many mistakes. My 4, so all of the numbers cancel. Y squared plus 4y equals 0. Y plus 4 equals, oops, sorry guys, 0. These are the y values. I'm going to attach them with the x. So at the points 1, 0, and 1, negative 4, that's where this curve is going to have horizontal tangent lines. Now, before we move on, I just want to remind you, way back in the beginning of the year, we actually dealt with these curves. Okay, this is actually the curve of an ellipse, and at the beginning of the year, we completed the square, and we found vertices and endpoints. Okay, we found these same vertices and endpoints using calculus now. 0, negative 2, 2, negative 2, those are our endpoints. Those are where I have vertical tangent lines. 1, 0, and 1, negative 4, those are my horizontal tangent lines. So it just gives you a little different way of looking at things. Now, last example, let's look at example 3. Hopefully this will move a little quicker. Example number 3, given x squared plus y squared equals 25. Let's find dy dx. Then we're going to find the equation of the tangent line at x equals 4 and see where the tangent line is vertical. So the first thing we're going to do, find dy dx. To find dy dx, we take the derivative of each term. If the term has an x in it, we write dx dx. If the term has a y in it, we write dy dx. So I have 2y dy dx equals negative 2x divided by 2y. So dy dx in this case is equal to negative x over y. Now we want to find the equation of the tangent line at x equals 4. I might just actually only do one of the lines. I'm going to talk about what I mean by that. Let's look at this equation. The original equation is a circle. Hopefully you guys realize circle radius 5. We have that. When x equals 4, we're actually going to have two points, right? So I was going to have you write both equations. Let's just do one. Let's save time. So I'm going to do the top. So I need to figure out, okay, if I want to write the equation of a tangent line, I need the point, I need the slope, and then I need to pop it into my formula. So when x is 4, we need to figure out for this top point what the y value is. So if I want to figure that out, I have to go back and use my equation. X squared plus y squared equals 25. Well, when x is 4, I want to figure out what y is. I have y squared is equal to 25 minus 16. So y is plus or minus 3. So obviously this point would be the 0.43, and this point would be the 0.4 negative 3. We're just going to save time here and write the equation for that point. So I have the 0.43. I need to find the slope, so I need to evaluate dy dx at the 0.43. So I'm going to take and I'm going to plug in to my rule negative 4 over 3. That's the slope at that point. Now now that I have my point and my slope, I'm just going to pop it into my formula there, right? So the equation of this line is going to be y minus 3 equals negative 4 thirds x minus 4. And there's the equation of the line. We could rewrite it if we want to, but there's no reason to because we're not being told to. Now let's see if we can remember from the beginning of the lesson. I want to find out the x values where the slope of the tangent line, where it's going to have a vertical tangent line. What does vertical mean again? Denominator equal to 0, right? So we're going to go back up to our derivative. That's where we get our slopes from. And we're going to set the denominator equal to 0. So we're going to have a vertical tangent line whenever y is 0. That was simple. So now we need to go back in and find x, because we were asked to find the x values. So I have x squared plus y squared equals 25. We're going to replace y with 0 and solve for x. X squared equals 25, so x is going to be plus or minus 5. Now, once again, let's think about this